In this demo, we're going to look at two-dimensional motion. We have this device, this cart here, that is going to have a ball inside, and the ball is going to get kicked up because there's a spring that's going to kick the ball up vertically as it passes this point. So there's a point here, and at this point, it's going to get triggered. The ball's going to go straight up. So the cart's going to go through this tunnel, and what I want you to do is think about what happens to the ball as this cart goes through the tunnel. Like I said, the ball is going to have this vertical velocity, the cart has a horizontal velocity, and what happens on the other side. So take a second to think about that. Okay, so what we're going to do now is to put the ball in. Now it's in there, it's going to get triggered at this point, it's going to get kicked up, and let's see what happens. Okay, so the ball comes back and falls into the cart, this container. It's able to go above the tunnel and fall back in its place where it started, and that's because it also has a horizontal velocity, not only the cart. So the cart has some horizontal velocity. The ball, in addition to the vertical velocity it gets by this kicking it up, it also has a horizontal velocity. So that's why it's able to go in a parabolic path and end up back where it was at the beginning, which is inside this container. So the container moves at a certain rate, right? So it has a certain horizontal velocity. So that's why the ball is able to basically track that cart and fall back to where it was. And this is illustrating how motion in two dimensions is independent. So the horizontal component of velocity is independent from the vertical component of velocity. So the vertical component is governed by gravity, which is pulling it down, but in this case we're trying to minimize friction, so the horizontal component should be fairly constant. So this is, again, a demo illustrating two-dimensional motion.